Yes, I just dropped off.
And we're live. This is quite exciting. So my name's Amy. I'm the data scientist and competitions lead at Zindi. We are very excited to be hosting our 5th Zindi weekends. This month, we're focusing on SDG 14, which is life below water. Our competition is, let me find it quickly. I'm going to be sharing my screen. Can everyone see my screen? Hoping so. So this is our competition, marine invertebrates classification. We have about 2,000 images of marine deep sea invertebrates, and your task is to competition invertebrates classification. We have about 2,000 images of marine. Okay, so whoever's on StreamYard, can you mute yourself so I don't hear myself? Okay, so we've got about 2,000 images across 137 different species. Here we have some of our different animals. They look like aliens, and it's really difficult to classify them. So this is why we need your help. I'm going to introduce Claire Davies from Seon. She is the data scientist lead and chief data scientist at Seon. Claire, I've got a couple of questions for you. Could you please tell me more about yourself and Seon?
Sure. Hi there, everyone. My name is Claire Davis-Reddy, and I'm the head data scientist at Seon. And Seon is the South African Environmental Observation Network. It's a division of the National Research Foundation, a government department in South Africa. And what we do is we try and improve open data products, open data research in order to facilitate effective decision making. So Seon itself has a wide variety of different environmental observations, networks across South Africa, all trying to understand our environment, terrestrial and marine in this case. And we collect data on a range of different things. And this hackathon focuses on a decade worth of pictures of marine invertebrates.
And why is collecting these invertebrates and classifying them so important?
So even though they might look a little bit strange, they're actually really important proxies of our changing climate. They tell us things that are happening without, the things that we're not observing we might be observing now. So these things are like corals, sponges, sea fans, sea slugs, starfish, and all of these they store information on changes in temperature, salinity, and all the things that are happening in our ocean. And that can give us an indication of whether the ecosystem is healthy or it's not actually doing so well.
Wow. I know that these images have quite a crazy collection story. And I know that the team spends up to a month on a boat out in the middle of nowhere. Could you explain a bit more about that?
Yes, so these photographs have been collected over the last decade, and they collected on annual trawling surveys. So a trawling vessel owned by the Department of Environmental Affairs in South Africa goes out normally January to February on the west coast of South Africa, and then basically conducts deep sea trawling and collects specimens. New species are discovered all the time. And normally they go out for a month or two, but during COVID, the researchers, shame, they were out there for the whole period, I think 6 to even 12 months, they were out on the ship because of all of the regulations.
That's crazy. I would have been so seasick for a constant 12 months.
And they're not fancy ships. They're very simple fishing vessels. So it's really quite challenging on the researchers.
On the competition page, we've actually got a video from one of the trawlers or one of the researchers on the trawlers. So you can be with them on that roller coaster of a ride. And so why is this competition, why is classifying these images so important? How will that help Seon?
So just as all image classification, if we look at classification of medical images, for example, x-rays. That is so important and provides diagnostic evidence for medical researchers and doctors. And it's the same case here. Image classification approaches, your deep learning algorithms or your simple classification procedures like your SVMs can actually give so much insight and give a process that's not manual. And that's the biggest benefit to SAON, is that no person needs to actually go and manually identify these hundreds and thousands of images collected over the last decade. And if we don't have people worrying about that they need to look at each individual images, it frees up our time to do so much more important work.
Incredible. Thank you so much, Claire. Do you have anything else that you need to share, or are you good?
No, I'm good. It's a great, exciting challenge.
Thank you so much for sharing your time with us.
Sure.
I will now be taking you through a starter notebook. We have a very new recruit to the Zindi staff team, Nazir from Nigeria. I'm pretty sure a lot of you Zindians already know him. He created the starter notebook, so I'm very excited to share it with you. Nazir will be on the discussion board this weekend, so if you have any questions, please reach out to him. Okay, and here we go. I'm going to share my screen. Yes, I have uploaded this notebook onto Colab. I find that Colab's the easiest way to work, especially because they have GPUs and my small computer definitely can't handle this data. The data is available on the competition. The competition is now live. And this notebook is just a quick blitz at a classification of 137 different classes, which is quite incredible. First steps first, we're going to mount our drive. We're going to make a directory, which is just called Invertebrates, and it's in our content folder. So it's right here at the front. We're going to add the train small and test small to our drive. The reason these files are called small is because we've resized these images to about 254 pixels, which is a fraction of the size of the original ones. So over here, we read in a lot of the files. Over here, we're going to unzip our files. Here we import our main libraries. We have NumPy and Pandas, which we're all comfortable with. We're going to be using FastAI. FastAI is absolutely brilliant. There's so much documentation on the web, so we recommend that you follow that. We've also got a couple of blogs on our Zindi Learn page. We're also going to plot some of the images we find. Now that we've read in the images, we're going to use this transformers. So this just shrinks the photo so you can get better pixels. We're also going to create more images by flipping them. I really recommend looking at more ways to do transformations, changing images to black and white, reflecting, mirroring, and all of that. We're then going to batch our data. So this is creating them just into smaller pockets. And we're just going to plot one of the batches. As you can see, they really are little aliens from the bottom of the sea. And really impossible to identify. We've also got some dirty data, meaning that we're not too sure what this is, but thankfully it's a prawn. So incredible spider-like crabs. This is a jellyfish that just looks like a blob out of water. So here we get to our machine learning or deep learning approach. We're going to use a convolutional neural net. It sounds very big and very scary, but with FastAI, it becomes really simple. We're using an accuracy error metric. So here we download our learner. We then take our learner model and fit it over 3 epochs. So here we can see the different losses it's getting. And it takes about 30 seconds to run each epoch. A good way to improve your model would be to run more epochs, change your learning rate. Now we're going to predict on the test set. So we're going to read in our sample submission file, and we're going to set our predictions to the sample submission. I'm just going to quit this. Here we have our submission file. Because we have 137 different classes, our file is going to have 138 columns. So for picture number 3E, it's not very likely that it's a Persta capaneus. Let's see if we can figure out what it actually is from our model. No, I couldn't tell you here. So yes, so you're going to be submitting this big file to Zindi. Here we have our submission file. Once you've got that submission file, you can go straight to Zindi to make your submission. There's many different ways to improve your accuracy, such as data augmentation, which I talked about earlier, which is black and white, flipping, mirroring, stretching, squishing. You can try other pre-trained models, such as EfficientNet. Can you use different sized EfficientNet models? As we mentioned, you can improve your number of epochs. And then you can do test time augmentations. As mentioned, we will be on the discussion board this weekend watching you. And we're really excited to share your solutions with Seon and hopefully see them put into production. I'm going to be staying on for the next 5 minutes if anyone has any questions. So last month, we also worked with Seon, where we did a road classification model. Seon does amazing work in South Africa, and their work actually spreads further than Africa. So I love working with them, and we love seeing your solutions on Seon's repositories. And if you've managed to get to 13 minutes on this YouTube video, I highly recommend looking at our new redesign. Our redesign was launched yesterday morning, so lots of new things to discover and find. We've been having lots of talks around Indaba X and hosting competitions for Indaba X. If there's an Indaba X in your country, I really recommend trying to find them. While talking to the organizations and partners, we've really been emphasizing that Zindi is a community, and that differs us from a lot of different platforms. One of the ways we show our community is through the discussion board, through teaming up. If you are a more experienced data scientist, I recommend reaching out to someone who is a bit newer, seeing if we can do some skill sharing across that. If you're new to Zindi, be brave enough to ask someone at the top of the leaderboard to team up, ask them for advice. The only wrong question is not asking a question, and we're all here to learn together. Oh, and And please send any pictures of us hacking or any of your faces when you look at these alien-like creatures. I remember the first time going through these pictures, and I think my face started to look like an alien with all the shock and horror. Remember, you can tag us on Twitter at Zindi.Africa, email them in, Facebook us, Instagram us, LinkedIn us. This video will be saved on Zindi, so if you need to come back, you can. And remember to hashtag building AI together. Thank you, everyone, and I really look forward to reviewing your solutions on Monday. Me and my data science team will be the ones reviewing. Good luck and have fun.